Hello everyone, my name is Apoorv Yadav from batch number 15, serial number 537. This is a video presentation on image counters with Opencv. So without any further ado, let's begin with our session. Now what are counters? Counters are defined as a line joining all the points along the boundary of an image that are having the same intensity. Counters come in handy in shape analysis, finding the size of object of interest and object detection. Typically, specific counters refer to boundary pixels that have the same color and intensity. Opencv makes it easy to find and draw counters in images. It provides two simple functions: find counters and draw counters. Also, it has two algorithms for counters detection: chain approx simple and chain approx none. Now, this is a algorithm which detects the counters of a simple object. As you can see, it detects the boundary of the shapes. This is known as counters. Now that you have been introduced to counters, let's discuss the steps involved in detection. OpenCV makes it a simple task. Just follow these steps. First, read the images and convert the images to grayscale format. Converting the images to grayscale is very important as it prepares the image for the next step. Converting the image to single channel grayscale is important for thresholding, which in turn is necessary for counter detection algorithm to work. The next step is applying binary thresholding. While finding counters, first always binary thresholding or canny edges detection to the grayscale images. Next, we find the counters. We use the find counters algorithm, which is a function to detect the counters in the image. And at last, we draw the counters on the original RGB image. Once the counters have been identified, using during the due to the draw counters function to overload the counters on the original RGB image. Now, let's see the applications of counters in computer vision. First, we have motion detection. In surveillance video, motion detection technology has numerous applications, ranging from outdoor security environments, traffic control, behavior detection in sport activities, detection of unattended objects, and even compression of video. Unattended. Next, we have unattended object detection. Any unattended object in public places is generally considered as a suspicious object, and hence counters help in detecting such objects and inform the policeman. Next, we have background and foreground segmentation. To replace the background of an image with another, we need to perform image foreground extraction, which is similar to segmentation, where many photographers use these counters to perform such activities. There are many such cool applications of counters in computer vision. Now, this is the Python implementation of image counters with OpenCV. First, we imported the packages OpenCV from Python. Next, we read the images from Python. This is the image which we have used in this example. First, we convert the image to image grayscale format. This is the image in grayscale format. Next, we draw counters using chain approx none. First, we start with find counters function, which is three required arguments as shown follow. Following arguments are optional. Please refer to the documentation here. And this is the documentation. First, we draw the counters of the original image. Next, we use drawCounters function to overlay the counters on the RGB image. The function has four required and several optional arguments. The first arguments below are required. For the optional arguments, please refer to the documentation page. This is the drawCounter function. This is the image file. We get an array of the images in the array format. And at last, we get the output using IMWrite. This is the counter which we have drawn through Opencv. Next, we draw counters using chain approx simple. First, we detect the image using chain approx sample using the binary files. Next, we draw the counters on the image file. And at last, we get the counters. This is the counters which we have developed through chain approx sample. At last, I would like to say in conclusion that we have counters detection algorithm in OpenCV which works very well and when the images has dark background and a well-defined object of interest. But when the background of the image input is clustered or has same pixel intensity as the object of interest, the algorithm don't fare so well. So you have all the code here. Why not experiment with different images now? Try images containing varied shapes and if different experiments threshold value. Also explore different retrieval modes using test images that contain nested counters. This way you can fully appreciate the hierarchical relationship between objects. In conclusion, I would like to say that you have started with counter detection and learned to implement that in OpenCV. Saw how the applications of counters for mobility detection and segmentation. Next, we also demonstrated the use of four different retrieval modes to counter approximate methods. You also learned to draw counters, and we concluded with a discussion on counter hierarchies and how different counter retrieval methods affect the drawing of an counter of an image. So the key takeaways are the counter detection algorithm in OpenCV works very well when images have draw background and a well-defined object of interest. Next, but when the background of the input image is clustered or have the same pixel intensity as the object of interest, the algorithm don't fare so well. These are the conclusions from this lecture. At last, I would like to say thank you and I hope you got some insight on image counters using OpenCV. Thank you.